Hello everyone, welcome to Think Global Education Services SAT Math class. Guys, the topic for today is modulus. So I believe you have heard modulus. So we can call it modulus, we can call it mod, or we also call it absolute value. So that's the concept. So let's understand what is this modulus, how does this work, and we'll see the application of this modulus in the questions for SAT. So guys, let's start. So I believe everyone is aware of very basics of modulus. So if I say mod of 5, what does that mean? Mod of 5 is 5. And if I say mod of minus 5, that's also 5. So the question here is, whenever we put negative inside the mod, it comes out to be positive. Why? There has to be some logical explanation towards it. So if I say mod x is equal to 5, then most of you will say that x, what's the value of x? X could be plus 5 or x could be minus 5. So the question here is, why does this happen? Whenever we put a negative inside the mod, it comes out to be positive. Now why this happens? Because modulus actually signifies the distance. Now can the distance be negative? No, the distance can never be negative. You never say I have traveled minus 2 miles today. No. So the distance can never be negative. So this modulus actually signifies the distance of this point, in this case distance of x, from 0 on the number line. So if you really understand modulus in the context of distance, this modulus will never trouble you. So when I say mod x signifies the distance of x from 0 on the number line. And guys, I believe everyone understands the number line. So this is 0, 1, 2, 3, 4, so on and so forth. Minus 1, minus 2, minus 3, minus 4, so on and so forth on this side. That's called the number line. So when I say mod x is equal to 5, what does that mean? That means the distance of x from 0 is equal to 5. Of course, on the number line. So the distance of x from 0 is equal to 5. So if I try to put this on the number line, the distance of x from 0 is always equal to 5. Now, if I go 5 points ahead, I'll reach plus 5. Similarly, if I go 5 points behind, I will reach minus 5. So there are two possible values of x. X could be 5 or x could be minus 5. Now, both values are actually 5 points away from 0. So this is how you actually analyze your modulus in the context of distance. Now let's try to go in more detail. So guys, we have learned that mod x is equal to 5. Now let's try to solve this. Mod x is greater than 5. The same thought process. We are looking for the values of x whose distance from 0 is always greater than 5. So if I go 5 points ahead, I will reach plus 5. If I go 5 points behind, I will reach minus 5. But this time I'm looking for the values of x whose distance from 0 is more than 5. That means anything here, x could be anything here which is more than 5 points away from 0, or x can be anywhere here also which is more than 5 points away from 0. So either x could be on this side or x could be on that side. So you see, x will always be more than 5 points away from 0. So if you try to write down the range, I can clearly see that x could be less than minus 5 or x could be greater than 5. So if you know the modulus, you actually directly know the range. And guys, one point to remember here, whenever you have a greater than sign, you always get a range beyond a particular point on this side, beyond a particular point on that side. Always like this. So whenever you have a greater than sign, you always get a range beyond a particular point on this side and beyond a particular point on that side. So let's take one more example. So if I say mod x is less than 5, so guys, I believe everyone will be able to read this in the context of distance. It's the same thing that we are looking for the values of x. So values of x whose distance from 0 is always less than 5. So if I go 5 points ahead, I'll reach plus 5. If I go 5 points behind, I'll reach minus 5. But this time they are looking for the values of x whose distance from 0 is always less than 5. So you can be anywhere here. If you really want to be less than 5 points away from 0, you can be anywhere here also. So this is the possible values of x. X could be here or x could be here, because the distance of x from 0 has to be less than 5. And I can clearly see the range that x is less than 5 and greater than minus 5. So I can say x is between 5 and minus 5. So if you know the mod, you directly know the range. And one point to understand here is whenever you have a less than sign, you always get a range between 2 points like this. You have a greater than sign, you get a range beyond a particular point on this side, beyond a particular point on that side. But if you have a less than sign, you always get a range between 2 points like this. Now, let's take this concept further. Now, guys, if I say mod x minus 2 is equal to 5. Now, how do we read this? Now, guys, I believe everyone will be able to read this, which was distance of x from 0 is 5. Now, this expression was actually this. Now, this minus 0 is so insignificant, we don't even bother to write it. But when we try to decode, it's actually distance of x from 0 is 5. So you see, this minus 0 is there, but we actually do not write it because it does not have any significance. Now, if I try to relate, this is the correct format. So when we write modulus, this is the correct format to write a modulus. Now, if we try to relate this format with this, so mod x minus 2 is equal to 5, how we will read this? So we'll simply read it distance of x from 2. Likewise, we did the distance of x from 0. Here we'll do the distance of x from 2 is 5. Now, if I try to analyze this on the number line, the distance of x from 2 is 5. Similarly, if I go 5 points ahead 2, I will reach 7. If I go 5 points behind 2, I will reach minus 3. So in this case, there are two possible values of x. X could be 7 or x could be minus 3. So I hope you get this. Whenever we say mod x minus 2 is equal to 5, that simply means the distance of x from 2. Now, guys, if I take one more expression, let's say mod x minus 2 is greater than 5. So I hope everyone will be able to read this. The same thing, the distance of x, this time from 2. The distance of x from 2 is always greater than 5. So if I go 5 points ahead, I will reach 7. And if I go 5 points behind, I will reach minus 3. But this time, the distance of x from 2 is always greater than 5. That means I want x should be more than 5 points away from 2. So x can be anywhere here or x can be anywhere here. It has to be more than 5 points away from 2. So likewise, the range will be x will either be less than minus 3 or x will be more than 7. So you see, again, if you notice, whenever you have a greater than sign, you always get a range beyond a particular point on this side, beyond a particular point on that side. So if you know the modulus, you directly know the range. So let's try to understand one more example so that it's super sure that we get it. Now, if I say this time mod x minus 2 is less than 5. So again guys, the distance of x from 2 is always less than 5. So if I go 5 points ahead, I'll reach 7. If I go 5 points behind, I reach minus 3. But this time I'm looking for the values of x whose distance is always less than 5. So x could be anywhere between this, or x could be anywhere between this. It has to be less than 5 points away from 2. So I clearly get the range that x will always be less than 7 or will always be greater than minus 3. So it's always between minus 3 and 7. And if you notice, whenever you have a less than sign, you always get a range between 2 points. So guys, I hope now you can read your modulus in the context of distance. So guys, we have learned this, but some of you might be thinking that what will happen if there is a plus sign in between? Do you realize I have taken all the examples with a negative sign in between? Now let's try to understand. If I say mod x plus 2 is equal to 5, now what will happen? Now guys, for that, let's understand a small concept. For example, if I say this is 0, this is 2, and this is 3. If I ask you what's the distance between 2 and 3, so the first thing that you need to learn is when I say modulus, that's a distance between 2 and 3, I know it's 1. And when I say mod 3 minus 2, that's also 1. So the first thing that you need to understand is if I say the distance of x from 2, or if I say the distance of 2 from x, that's the same thing. It does not have any difference. So it's like saying the distance from New York to Chicago or the distance from Chicago to New York. So it does not make any difference. So the point here that I'm trying to make here is till the time you have a negative sign in between, you are good to go. So whether I say x minus 2 or whether I say 2 minus x, that's exactly the same thing. Now, I asked you the distance between 2 and 3. So what do? You'll take this distance, which is 3, you subtract this distance, which is 2, and you'll get the distance between 2 and 3, that's 1. So if you notice, to figure out the distance between 2 points, you have to subtract something from something to get something in between. So when we really analyze the distance between 2 points, there has to be a negative sign in between. So this plus sign does not exist. So when I say mod x plus 2, this is actually not plus. I just combine two negatives and then write it. So this is the correct format. So remember guys, whenever you are dealing with the distance between 2 points, there has to be a negative sign in between. If you face a plus sign, that's actually not plus. They just combine two negatives and write it positive. Now I think most of you, everyone can actually read this in the context of distance. So how will I read it? Distance of x from minus 2 is 5. So if I try to draw this on the number line, the distance of x from minus 2 is 5. So if I go 5 points ahead minus 2, I will reach 7. I will reach 3. And if I go 5 points behind minus 2, I'll reach minus 7. So in this case, the two possible values of x are 3 or x could be minus 7. So if you have negative, very good, I can directly read it. If you do not have a negative sign, that means you have a positive sign. So you don't have to worry. What you need to do, it's nothing but just the combinations of two negative, and I can still read it in the same format. So guys, till now what we have learned that if I give you the modulus, you can actually give me the value or you can give me the range. If I know the mod, I should directly know the range or the value. So guys, let's try a few questions based on this. Now in the first question, it says mod 8 minus b is equal to 12 and mod 13 minus b is equal to 17. So let's decode the first mod, which is mod 8 minus b is equal to 12. Now see there's a negative sign in between. So whether I say 8 minus b or whether I say b minus 8, that does not make any difference, and then still the same thing. So let's figure out this mod. This simply means the distance of b from 8 is 12. The distance of b from 8 is 12. So if I go 12 points ahead here, I will reach 20. If I go 12 points behind, I will reach minus 4. So according to this equation, there are two possible values of b. B could be 20 and b could be 4. Okay. Now let's decode the second modulus, which says mod 13 minus b is equal to 17. Now again guys, whether I say 13 minus b or whether I say b minus 13, that's the same thing. So till the time I have a negative sign in between, there is no problem. So how will I read it? The distance of b from 13 is 17. So if I go 17 points ahead on the number line, I will reach 30. And if I go 17 behind the number line, I will reach minus 4. So according to this equation, b is 30 or b is minus 4. Now when I read the question further, it says b satisfy both the equations above. So if b satisfy both the equation above, I can clearly see that there is only one value that same in both the equations. So if b satisfies both the equation, I can clearly see that b is nothing but minus 4. But be careful guys, that's not my answer. The question is asking what's the value of modulus of b. So if I know b is minus 4, so mod of b is mod of minus 4, which is nothing but 4. So my answer is 4. So you see guys, you really don't have to solve the modulus. If you can read the modulus in the context of distance, these questions will be very, very easy. So guys, let's take one more example and try to figure out this. This is based on the similar grounds. Now you see, when I say the first modulus, mod p plus 7 is equal to 8. Now guys, I told you there's a plus sign which does not exist in a modulus. So it's actually not plus. They have just combined two negatives and written one positive. Now it is in the correct format. So how we will read this? The distance of p from minus 7 is 8. So if I go 8 points ahead, I will reach plus 1. If I go 8 points behind, I'll reach minus 15. So according to this equation, p has two values. So p could be 1 or p could be minus 15. Similarly, if I solve the second modulus, which is q minus 2 is equal to 12, that's a pretty easy one. That means the distance of q from 2 is 12. So if I go 12 points ahead, I'll reach 14. If I go 12 points behind, I'll reach minus 10. So according to this, q could be 14 or q could be minus 10. But if I read the question further, they are restricting that p has to be less than 0 and q should also be less than 0. So if p is less than 0, this is the only value which is less than 0 for p. And if q is less than 0, this is the only possible value for q. So from there I get that p is minus 15 and q is minus 10. Now they are simply asking you what's the value of q minus p. So q is minus 10 minus p is minus 15. Be careful of the sign here. Minus 10 plus 15. So q minus p will come out to be 5. So you see again, if you just know how to read the modulus in the context of distance, these questions will become fairly easy. Okay. Now guys, there is another type of question, which is this, and it's a trick question. If you read the question, it says n is a number which lies between m and minus m. Which of the following is definitely true? Now guys, when I say what is the sign of minus m, most of us say negative because they see a negative in front of it. But you have to be very cautious. I asked you the sign of minus m. Minus m, you see, if m is positive in itself, the entire expression will become negative. If m is negative in itself, the entire expression will actually become positive. So you have to be very careful when someone asks you what's the sign of minus m, that does not mean negative. It totally depends on m. If m is positive, the expression will become negative. And if m is negative, the entire expression will become positive. Now in this question, they said that n is a number which lies between m and minus m. Which of the following is definitely true? Now in this question, they are asking me, is m greater than 0? They do not give me any clue, no clue about m. So if they do not give me any clue about m, how can I say that m is greater than 0? So this is not true. Similarly, if I have no clue about m and n is a number which lies between m and minus m, I really have no clue about n. So if m could very well be positive or negative, similarly n could be very well be positive or negative, and hence minus n could also very well be positive or negative. So I really have no clue regarding m or n. So the first and third statement does not make any sense. They straight away cancelled out. But for the second statement, which is mod of n is greater than equal to 0, I really don't need the question on the top to prove this. It's a universal statement. Universal statement. This is always true because I know that modulus is nothing but distance. And the distance will either be greater than or equal to 0. The distance can never be negative. So I really don't care what is the value of n. Mod of n will definitely be 0 or greater than 0, which is perfectly true. So if I look at this, the answer is straight away A, that is statement number 2 only. So you just have to know this fact regarding the modulus, that the modulus is nothing but the distance, and the distance can never be negative. It will either be 0 or it will be greater than 0. Now guys, keeping this fact in mind that the distance is always greater than equal to 0, let's try one more question which is actually testing me on this particular logic only. Now this question says mod x minus 5 is greater than 2 plus p, where p is a constant. For what value of p will the inequality be true for all the values of x? Okay. So that means I want this inequality should always be true. The inequality is mod x minus 5 is greater than 2 plus p. So they are simply asking me, if I decode the language, they're asking me for what values of p this inequality will always be true. So what should I put in place of p so that the inequality always holds true? Now guys, the answer here is A. But let's understand why B, C and D is not my answer. If I try to decode this inequality, I know the left hand side will either be 0 or positive because it's a modulus. So the left hand side will always be 0 or positive because this modulus cannot be negative. So this will either be 0 or this will be positive. Now if I go for option number B, so the left hand side will always be 0 or positive, and if I replace p as minus 2, the inequality will become 0. So the inequality does become the left hand side is 0 or positive, the right hand side is 0. So when you look at this inequality, is this inequality always holds true? Not always, because it could be 0 or it could be anything positive. If it's positive, this will hold true, but if the left hand side is 0, it will not hold true. So not always. That's why option number B is not correct. Similarly, if I try option number C, you see the left hand side will always be 0 or positive, and if I replace p as 2, it will become greater than 4. So is the left hand side greater than 4? Might be, might not be, because if the left hand side becomes 0, then it will be not greater than 4. If it's 5, it will be greater than 4. Again, we get not always. So this might be true, might not be true. But as you can see, we are looking for always true. So similarly, C goes. Now if I go for D, I know that the left hand side will always be 0 or positive. If I replace 5 in place of P, the right hand side will become 7. And when I look at this inequality, is left hand side greater than 7? Might be, might not be. So again, not always. So I just solved all the options to make a point that why B, C and D are not my answer, because they are not always true. But if you quickly check option number A, the left hand side is 0 or positive. And if I replace minus 5 in place of P, I'll get the right hand side as minus 3. So when you look at this inequality, is your left hand side greater than minus 3? Yes, because if I put 0, then also it's greater. And if I put any positive number, of course it will be greater than minus 3. So under every circumstance, it will always be true. Is which of the following options is true? Option number A. So guys, that's how you do code your modulus. You just need to understand that the modulus is nothing but distance, and the distance can be 0 or it can be positive, but it will never be negative. So if I replace minus 5 in place of P, I'll get the right hand side as minus 3, and any which way, the left hand side, no matter whatever you do on the left hand side, it will always be greater than your right hand side, and hence this inequality will always hold true. So guys, I hope you understand this modulus. Now, guys, we have done modulus and converting that modulus into range. So what we have learned till now, if I give you the modulus, we can read it in the context of distance and we can figure out the range. But we can actually go vice versa also. So if I give you the range, you should give me the modulus back. So it's a vice versa process, modulus to range, range to modulus. Now let's understand how do we reverse the process. Now guys, for that there's a small logic. So let's understand the small logic. So if I say this is a number line, this is 2, this is 10. Now guys, if I ask you the point which is equidistant from both 2 and 10, that means the point which is equidistant from 2 also and from 10 also. In that case, that point is 6. As you can clearly see that 6 is 4 points away from 10 and it's also 4 points away from 2. So if you realize 6 is nothing, it is just the average of both the points, that is average of 2 and 10. So I can make a statement here that the average of both the points will always be equidistant from both the points. The average of both the points will always be equidistant from both the points. Now this logic is actually used to reverse the process. Now let's understand how. So for example, if I give you the range that x is always less than 10 greater than 2 and I want to write down the modulus. So guys, very easy. What's the first step? The first step is to draw the range. So if I draw the range, let's say x is 2 here and 10 here. So x is always greater than 2, less than 10. So I know the range. The range is always between 2 and 10. Second step, take the center point. The center point, as I already told you, is nothing but the average of 2 and 10. Now, I know that x is always in the shaded part. So x could be anywhere in the shaded part. So x could be here, x could be here, x could be here, here. So x could be anywhere in the shaded part. So you can take wherever you want to take x. So let's say I take x here. Now let's try to analyze the distance of x from this center point. That means the distance of x from 6. So if I try to analyze this distance mathematically, I can directly express it like this: the distance of x from 6. So basically we are analyzing this distance. Now I can clearly see on the number line that the distance of x from 6 will always be less than this distance, which is the distance of 6 from 10, which is 4. So I can clearly see that this blue distance, the distance of x from 6, will always be less than 4. So you see, if I know the range, I directly got the modulus. So from range to mod, and if I know the modulus, I can get back to the range. So the distance of x from 6 is always less than 4. If I go 4 points ahead, I'll reach 10. If I go 4 points behind, I will reach 2. But I'm looking for the values of x, whose distance from 6 is always less than 4. So I can be anywhere here or anywhere here. So what's the range? X is less than 10 or greater than 2. So you realize if you know the modulus, you know the range. So modulus to range and range to modulus. So you should be good in converting your range to mod or your mod to range. So I hope this is clear, guys. Now let's take one example to understand this question. So here, guys, this question is actually dealing with conversion of range back into modulus. Now here they say that average speed of train A is at least 70 miles per hour and at most 100 miles per hour. If the journey is 7,000 miles, so the distance is given to me 7,000 miles. Which of the following equations represents all the possible values of time taken? So guys, be careful. I want the equation which represents all the possible values of time taken t by the train to complete the journey. So my focus is on t. Now, guys, I know that the distance is 7,000 miles. Now, common sense, if I want to figure out the range of t, so if I want the train to take the minimum time, so do you realize the speed should be fastest? As I can see, the distance is always 7,000. If I want the time taken by the train to be minimum, the speed of the train should be maximum, which is 100 miles per hour. So from there, I realized that the minimum time that is taken by train is 70 hours. Similarly, if I go for the maximum time taken by train, now common sense, if I want the time to be maximum, the train should go with the minimum speed. Now the minimum speed here is 70 miles. And I know, guys, time is nothing but distance over speed. So here, from here, I'll get the maximum time as 100 hours. So do you realize the objective of this word problem was to give you the range of time? So I can clearly see the time will either be less than equal to 100 or greater than equal to 70. So it will be at least 70 hours or at most 100 hours. So I got the range of time and they're simply asking me which of the following equation represents all the possible value of time taken. So guys, I've just told you if I know the range, I can convert this back into modulus. And how will I do that? First of all, I will draw the range. So the range of t is from 70 to 100. So this is 70, this is 100. So the range is from 70 to 100. Then what will I do? I will simply take the center point. Center point means the average of 70 and 100, which is 85. Now, t can be anywhere. T can be anywhere in the shaded part. So let's say t to be here. Now what I'll do, I'll simply take the distance of t from 85. That means we will analyze this distance, which is this red distance, the distance of t from 85. How will I express it mathematically? T minus 85. So I got the distance of t from 85 and I can clearly see that the distance of t from 85 will always be less than this distance, which is the distance from 85 to 100, that's 15. And it could be here also, so it could be equal to 15 also, or it could be less. So I can clearly observe that the distance of t from 85, no matter whatever you do, will always be less than or equal to 15. And if I look at the option, that is option number C. So you see, this is how they will give you a practical question of converting range to modulus. So either they ask you to convert range to modulus, or they will ask you to convert modulus to range. So that's it, guys. If you are able to read your modulus in the context of distance, these questions become very easy and you can directly handle them. So I hope, guys, now the modulus is clear. I hope you enjoyed this class. So that's all from my side, guys. We'll meet again with the next topic. Thank you.